You know what cold feels like. Step outside in winter. Feel it hit your face, that biting sensation on your skin, the way your fingers go numb, the shiver that runs through your body. Cold is obvious. Cold is real. You've felt it 1,000 times. But here's the thing. That sensation you call cold, that thing you think is touching you, entering you, making you uncomfortable, it doesn't exist. Cold is not a thing. Cold is not a substance. Cold is not an entity that can touch you or enter you or do anything to you at all. When you say you feel cold, you're wrong. Not a little wrong. Fundamentally wrong about what's actually happening to your body. So what are you feeling? If cold doesn't exist, what's that sensation? What's making you shiver? The answer changes everything you think you understand about temperature, about heat, about the physical world around you. And once you see it, you can't unsee it. Let me show you. Put your hand on a metal railing on a winter day. Freezing. Painful almost. Now put your hand on a wooden bench right next to it. Same air temperature, same environment, same winter day. But the wood feels warmer. Noticeably warmer. Why? Why? You might say metal is colder than wood, but that's not true. They've been sitting in the same air for hours. They're in thermal equilibrium. A thermometer would read exactly the same temperature for both surfaces. Identical. No difference at all. The standard answer is that metal conducts heat better than wood. Fine. But think about what that actually means. Really think about it. The metal isn't colder than the wood. They're the same temperature. They've been sitting in the same air for hours. They're in thermal equilibrium. Identical temperatures. But one feels colder, dramatically colder. How can two things at the same temperature feel so different to your hand? Because you're not feeling the temperature of the object. You're feeling heat leaving your body. The metal conducts heat away from your hand faster than the wood does. Much faster. Metal atoms are arranged in a crystal lattice that transmits vibrations efficiently. Your hand's heat flows into the metal rapidly. More heat leaves through the metal. Your hand cools down faster. Your nerves detect that rapid heat loss, and your brain interprets it as cold. You're not feeling cold entering your hand. You're feeling heat exiting your hand. The sensation is backwards from what you think. Cold doesn't go into you. Heat comes out of you. That's what you feel. That's what cold actually is. The absence of heat. The removal of energy. Not a thing, but a lack of a thing. This should bother you. Your entire life you've thought of cold as something real. Something that exists out there in the world. Something that attacks you in winter. Something you need protection from. Something that can hurt you. But cold isn't attacking you. Your own heat is abandoning you. The danger isn't something coming in. The danger is something going out. Now let's go deeper. What is heat in the first place? You think of heat as a substance too, don't you? Something that flows from hot things to cold things. Like a fluid. Like water running downhill. That's how people thought about it for centuries. They called it caloric. An invisible fluid that moved between objects. Hot objects had lots of caloric, cold objects had little. When you put them together, caloric flowed from high concentration to low concentration until it balanced out. It was a beautiful theory. Elegant, it explains so many observations. Heat flows, heat spreads, heat seeks equilibrium. All of this made sense if heat was a conserved fluid. Scientists wrote equations based on caloric theory. Engineers designed steam engines using caloric theory. It worked. Wrong. Heat is not a substance. Heat is not a fluid. Heat is not a thing at all in that sense. Heat is motion. Take any object, a cup of coffee, a block of ice, your own body. Zoom in, keep zooming, past the surface, past the visible structure, down to the molecules. What do you see? Motion. Everything is moving, vibrating, jiggling, bouncing around. The molecules in that cup of coffee are shaking back and forth, rotating, colliding with each other billions of times per second. They never stop. They can't stop. As long as the temperature is above absolute zero, they're moving. That motion is heat. That's all heat is. The kinetic energy of molecules. The vibration of atoms. the jiggling of particles. When something is hot, its molecules are moving fast. When something is cool, its molecules are moving slower. That's the only difference. Speed of molecular motion. Temperature is just a measure of how fast the molecules are jiggling. High temperature means fast jiggling. Low temperature means slow jiggling. That's it. Nothing more mysterious than that. So what happens when you touch something hot? The fast-moving molecules in the hot object collide with the slower-moving molecules in your hand. Energy transfers. The fast molecules slow down a little. The slow molecules speed up a little. Your hand gets warmer. The hot object gets cooler. Energy flows from fast to slow, from hot to cold. Now flip it around. What happens when you touch something cold? Same thing, but in reverse. The fast-moving molecules in your hand collide with the slower-moving molecules in the cold object. Your molecules slow down. The cold object's molecules speed up. Energy flows out of your hand into the object. You feel that energy leaving. Your nerves detect the drop in molecular motion in your skin. Your brain interprets that signal as cold. But nothing entered your hand. No cold substance. No cold fluid. No cold anything. Energy left. That's all. Cold is the name we give to the sensation of losing heat. It's not a thing. It's an absence, a direction, a flow going the wrong way from your body's perspective. Here's another way to see it. Can you add cold to something? Think about it carefully. You want to cool down a drink. How do you do it? You put ice in it. But what's actually happening? Is the ice adding cold to the drink? No. The drink is adding heat to the ice. Energy flows from the warmer drink into the colder ice. The ice molecules speed up. They speed up so much that the ice melts, changes state, becomes liquid water. The drink molecules slow down. The drink gets cooler. You didn't add cold. You added something that would absorb heat. You provided a place for the drink's energy to go. The cold didn't flow into the drink. The heat flowed out of it. You can never add cold to anything. You can only remove heat. Cold is not something you can possess, transfer, or give. Cold is what's left when heat is taken away. Think about a refrigerator. You probably think it makes things cold. It produces cold. It generates coldness somehow. You plug it in and cold comes out. Wrong. A refrigerator is a heat pump. It takes heat from inside the box and moves it outside the box. Feel the back of your refrigerator sometime. It's warm, sometimes hot. That's the heat that used to be inside. The refrigerator didn't create cold. It relocated heat. It pumped energy from one place to another. The inside got colder because heat was removed, not because cold was added. This is not an obvious thing. For centuries, people tried to create cold directly. They failed because you can't create something that doesn't exist. You can only move the thing that does exist. Heat. Energy, molecular motion. Air conditioners work the same way. They don't produce cold air. They remove heat from the air inside your house and dump it outside. That's why there's a hot exhaust. That's why the compressor is warm. That's where the heat goes. You're not adding cold to your house. You're subtracting heat from it. Every air conditioning unit is a heat relocator, a thermal moving company, taking energy from where you don't want it and putting it somewhere else. This is a fundamental law of the universe. Heat flows from hot to cold, always, never the other way. You can't make heat flow from cold to hot without doing work, without spending energy to force it. Refrigerators do that work. Heat pumps do that work. But they're not creating cold. They're fighting the natural direction of energy flow. Now let's go to the extreme. How cold can something get? If cold is just slow molecular motion, what happens when you slow the molecules all the way down? What happens when they stop completely? You might think you can keep cooling forever. Just keep removing heat. Keep slowing those molecules. Keep taking energy away. Why would there be a limit? But there is a limit. There's a floor, a bottom, a point beyond which you cannot go no matter what you do. That's absolute zero. Minus 273.15 degrees Celsius, minus 459.67 degrees Fahrenheit, 0 Kelvin, the bottom of the temperature scale, the point where molecular motion ceases. The coldest possible temperature, the end of the line. At absolute 0, molecules stop vibrating. They stop jiggling. They stop doing anything at all. They reach their lowest possible energy state. Complete stillness. Perfect quiet. You can't go any colder because there's no more motion to remove. You've extracted all the heat. There's nothing left to take. You can't have negative motion. You can't have less than 0 energy. Absolute 0 is the floor. But here's the thing that should bother you. You can never actually reach absolute 0. It's physically impossible. Not just difficult, impossible. A fundamental law of thermodynamics forbids it. The closer you get, the harder it becomes to remove more heat. You can get incredibly close. Scientists have cooled atoms to billionths of a degree above absolute 0. But you can never quite get there. The laws of thermodynamics forbid it. So absolute 0 is a limit, a boundary, the floor of temperature, and cold is just how far you are from having any molecular motion at all. Think about what this means for the universe. Space is cold. The average temperature of the universe is about 2.7 Kelvin, just a few degrees above absolute 0. Almost nothing. The cosmic microwave background radiation, the leftover glow from the Big Bang, that's all the heat there is in most of space. A faint whisper of warmth from an explosion 13.8 billion years ago. Almost nothing, almost 0 molecular motion, almost complete stillness. The universe is cold by default. Cold is the natural state. Cold is what you get when there's nothing happening. No energy, no motion, no heat being generated. Cold is the baseline. Cold is where everything ends up eventually. Heat is the anomaly. Heat is the exception. Heat is what happens when something releases energy. Stars burn and produce heat. Planets retain heat from their formation. Living things generate heat through metabolism. But these are exceptions. Islands of warmth in an ocean of cold. You live on one of those islands. Earth is warm because the sun pours energy onto it constantly. About 173,000 terawatts of power hitting our planet every second. A staggering amount of energy. Without it, Earth would cool to the background temperature of space within weeks. We exist because of a constant energy subsidy from a nuclear furnace 93 million miles away. Your body is warm because you burn food and release energy constantly. You are a heat engine, converting chemical energy into thermal energy every second of your life. About 100 watts, roughly the same as a light bulb. That's how much heat you produce just sitting there. When you exercise, it can go up to 1,000 watts. You're a furnace, a small biological furnace running on sandwiches and oxygen. And you're constantly losing that heat, radiating it into the air, conducting it into objects you touch, evaporating it away when you sweat, exhaling warm breath into cold air. Your body fights to maintain its temperature against a universe that wants to drain your energy away. That fight is what keeps you alive. The moment you stop producing heat, the moment your metabolism stops, you start cooling. And you keep cooling until you reach equilibrium with your surroundings. That's what death looks like from a thermodynamics perspective. You stop fighting entropy. You stop replacing the heat you lose. The universe wins. When you feel cold, you're feeling that fight getting harder. You're feeling heat leaving faster than your body can replace it. You're feeling the universe winning, bit by bit, pulling energy out of you and spreading it thin. Cold doesn't attack you. The universe is just taking back the heat you borrowed. Here's one more thing that should change how you think about this. Your ancestors didn't understand any of this. For most of human history, people believed cold was a substance, something real that could be added or removed. They thought cold could penetrate objects, invade bodies, cause disease. Cold winds carried cold into your lungs. Cold water put cold into your muscles. It made sense based on how things felt. But feelings lie. Your senses evolved to keep you alive, not to accurately represent physics. Your body doesn't care whether cold is a substance or an absence. It just needs to know when to shiver, when to seek shelter, when to find warmth. The sensation works fine for survival. even though the underlying model is completely wrong. You feel cold as something real, because that feeling kept your ancestors alive, not because cold is actually real. Now you know better. Cold is not a thing. Cold is what's left when the thing is gone. Cold is absence. Cold is the default state of a universe, where heat is rare and precious and constantly trying to spread itself thin. The next time you step outside on a winter day and feel that biting sensation on your skin, remember what's actually happening. Nothing is entering you. Nothing is attacking you. Your heat is leaving. Your molecular motion is slowing. Your energy is draining away into an environment that has less energy than you do. That's not cold touching you. That's you touching cold. And cold isn't anything at all. You're feeling your own heat escaping. You're feeling energy flow in the direction it always flows. You're feeling the universe doing what it always does, spreading energy out, evening things up, moving toward equilibrium. Cold doesn't exist, only heat exists, and heat is leaving. That's what you're actually feeling. Not a presence, an absence, not something coming in, something going out. Not an attack, a departure. The chill on your skin is your own warmth saying goodbye, and there's nothing you can do but make more heat, burn more fuel, keep fighting, because the moment you stop, the cold wins. Not because cold is powerful, because cold isn't anything at all, and nothing always wins in the end.